Hello, this is Brian Castles for Lattice Semiconductor. I'm going to cover several key concepts in this presentation, specifically on Diamond projects, so implementations, strategies, and folders, and then shared memory, and then context-sensitive views. So here we have open the Lattice Diamond software. I'm going to open an existing project. And let's take a look at the file list. In the file list, you can see the device that the project is being targeted at and implementations and strategies. Implementations and strategies are a new concept in the Diamond software. Implementations basically are different structural representations of your design, and strategies are the recipes or formulas used to implement those implementations. So in this example here, you can see that we have 3 different implementations, and I can switch as to what is the active one by right-clicking on one of them and saying set as the active implementation. If I open the existing active implementation, you'll see I have a number of folders inside of it. In the input files are the normal source files for your design. In Diamond, you can have edif, VHDL, or Verilog all mixed freely together in the same implementation in a single project. So you don't have to have different projects for different file types. In addition, for each source type, I can take and right-click on it, and I get this menu, and I can do things like I can exclude it from the implementation, so I can keep it in the source list but just not have it be included. And I've also got an include for option in Diamond 1.3. That a source file can be used either for synthesis and simulation, or for synthesis only, or for simulation only. So I can target where the source is going to be used. So in this case, these 2 files are used for simulation and synthesis. This file here is used for both also, but this test bench is used for simulation only. And you can see that here. So you can control what the input source is used for. New in Diamond 1.3 also is a new synthesis constraint file folder. These are both SDC and LSC files are synopsis design constraint format files, and I can open them and edit them in the Diamond also. So these go here. In previous versions of Diamond, these were used but were not included in the source file list. Now it is. We have the LPF constraint files. These are the constraint files used by the backend processes, so map and place and route. And I can have multiple files in here, but only one can be active at a time. And I can control which one is active by right-clicking it and setting it as the active preference. The debug files folder is for the reveal hardware debugger, so I can control whether to insert debug into my design or not. And I can have one or more of these debug files, and if it's active, it will be inserted. If it's not active, I can keep it in the list, but it will not be inserted. So in this case, it is active. I can set it as inactive if I want to. Script files are script files produced by the simulation wizard. And the analysis file folder shows files that are used either by Power Calculator, which are the PCF files, or by our Atomic Analysis tool, which are the TPF files. And again, I can have multiple of each of these types, and I can set them to be active or not active by right-clicking on them. And finally, new in Diamond 1.3 is a programming files folder, and this contains XCF files, which are used by the Diamond Programmer tool. And again, I can have multiples of these, and I can take and set them active or inactive, same as the other file types. So this is an example of what's contained inside of an implementation. In addition to the implementation, I have strategies. And here you can see I have 4 predefines, which always come with, new with a project, and I have a couple of user-defined strategies. Strategies basically are all the settings that are used by the implementation tools. You see that it opens in this dialog, and in this dialog I can set different preferences for any of the different stages. If you look at preferences that have been set in here, if I take and click on one of them, I can take and change the value, and if I change the value to be something other than the default, you see the default ones are blue, and any that I've changed from default show in the red. And strategy files can be saved. All strategies are shared across the implementations inside of a project, and they're also saved out as files, so you can actually share them in other projects also. You notice in the strategy list that one is bold here. That sets the active strategy. So every implementation must have an active strategy. If I switch to a different implementation, I can set a different strategy to be the active one for that. So I'll set that as the active strategy. And now if I go back to that first implementation we were looking at and set that as the active implementation, you'll see that we're back to the original strategy that was active. The strategies themselves are shared across all the implementations inside of a project. Next, I want to cover the idea of shared memory. So let's open one of our tool views. We'll open the spreadsheet view. Expand this. Let's also open the package view. So here in these views, I can go, for example, into the spreadsheet view, and you can see I've got some pin assignments here. And I can go and assign a pin. And so I've assigned a pin here. You'll notice in the tab here I've got an asterisk after the name that shows that the contents have been changed and that these contents are in memory, have not been saved yet. But you'll notice in my package view that it has an asterisk there now also. Since this shows the pin assignments and I've changed a pin assignment, it reflects that change. So that change in memory is being shared between the spreadsheet view and the package view. So that's the concept of shared memory, that what I do in one tool view may easily affect something else that's in another tool view. And if I take and close these views, let's close the package view and the spreadsheet view. Now remember, the change is still in the shared memory. If I open the spreadsheet view again, you'll notice that it still has the asterisk here. Until you close the whole environment, that change is still shared in shared memory and kept there. So next I want to look at our process view. So here I want to show dynamic data updating. So here you can see I've run processes through map. I have not run place and route here. So if I open the spreadsheet view again, you see the pin assignments here. If I take and actually run place and route, you'll see that pin assignments that I have not directly assigned will be done by the place and route tool. And so let's take and run place and route. So now that that's complete, you can see it reloads the data, so I can see all these pin assignments here. So it shows two things. Number one, it shows that the data is dynamically updated. The other thing it shows is that in Diamond there are not separate views for pre-map and post-map, for example. In the previous ISP lever tool, there were separate views for looking at pre-map data or post-map data or other types of data. In Diamond, all the views show specifically the data that's available there. Next, I want to show cross-probing capability between some different views. So let's open floor plan view and physical view. And here in physical view, I can take and go and select on a signal, for example, and then I can right-click and say Show In. And I have available floor plan view as one choice, and I can say Show in floor plan view, and you can see it jumps to floor plan view and shows that information there. So this is cross-probing between different views. And depending on which data I have selected, I have different capabilities of seeing this. So for example, if I go back to spreadsheet view and right-click on this pin, you can see I can show this in package view, device view, netlist view, NCD view, or floor plan view. So all depending on which type of data I have selected, I can cross-probe in a number of other different tools, depending on whether that data is applicable in those tools or not. So in this video, we've explained several key concepts in the Lattice Diamond software, implementations, strategies in folders in Diamond projects, the concept of shared memory and how it's used across the various Lattice Diamond tools, and then context-sensitive views and how those appear in the Lattice Diamond software. I hope this has been helpful. Please also view some of the other videos available on the Lattice website for more information on the Lattice Diamond software.